We're now testing the rudder, and you can see movement of about 25 millimeters at least at the bottom. The top, we have a lot of free movement in the bearing, which is housed within the hull, and obviously from the emergency rudder position you can see some movement. Again, movement where the steering is attached, and we also found that the cables are currently slack. We're now extracting the copper bearing, which is really just pushed into the hull. You just ease it out. You can see where the wear has occurred to the side of this bearing, mainly side. The split, it actually should be in line with the hull at the sort of forward end, and now we tightened it up. Look at the gap is much tighter, so there's quite a lot of wear to the inside of the hull section where the copper fits. Now our aim is to actually now reduce the size of the hull hole, and we came up with an idea that we didn't want to do what a lot of other people have done, was to take that copper bearing, tighten it together with tape and then stick it back in with some sort of adhesive. Instead, this is our main idea, that we would form a fiberglass shell attached to the copper bearing, which we're now applying a releasing agent onto. So when we attach our fiberglass collar, which we're going to stick it straight onto the bearing on top of the agent, it will compress the copper onto the shaft bearing, and this will allow us to slip it off the bottom shaft bearing and put it into the hole at a smaller diameter, which will then glue into that hole in the hull. Obviously what we've done is tighten it up, the bearing, using a pipe clip. We applied a bit of grease to give it some movement, but with the pipe clip, if you tighten the pipe clip as far as you can so that you cannot move the copper, so it's as tight as it can go onto the shaft, then back off a couple of turns on the screw to give you the free movement of the copper sleeve split bearing on the shaft. The reason they're putting the grease in the gap there is because when we put the epoxy on and fix the very thin fiberglass matting in two sections, small thin section on the top, you'll see what we're doing. This will then hold the bearing in its new tight position once it's gone off, and we can remove the pipe clip, leaving us with a copper bearing and a cylindrical sort of a fiberglass band fixed around it. Now, the original design was that the copper was completely independent from the fiberglass hole in the hull, so we're hoping that once we've put the fiberglass onto this copper bearing, it will eventually, being submerged in water, that the PVA releasing agent we applied, and it's got to be PVA, you can purchase it on eBay, will dissolve in the water, and this will free the copper bearing from this bandage we're sort of attaching. Once it's free, well, it will happen when it's in the water during the season. We put the fiberglass on, and now just going over the top of it to build up the layer of resin. The thing to note about this is that this was done in temperatures of 10 degrees, and we had to apply heat or put some sort of heat around it to get the resin to harden. Unfortunately, it requires at least 20 degrees to cure. It takes about 3 hours. Now we can see that the fiberglass has cured itself, and we can remove it from the stock bearing. It is now uneven, so will not totally fit into the hole. Having removed the pipe clip, everything rotates nicely, and it feels tight onto the shaft. The cap is now reduced. You can now test to see if it fits the hole, which it nearly does. It's a little oversized, so all we need to do is sand it until it fits snugly into the hole. I would not suggest that you force the bearing into the hole, as this will compress it, and the possibility that the rudder stock will get jammed. We intend to apply epoxy resin to the external bearing now and insert it into the hull. Once this has been totally inserted, we pushed up using the rudder and the rudder stock itself, forced into position, and support the rudder or wedge the rudder up from below and leave it to cure for at least 2 days. It's important just to rotate the bottom washer to ensure it doesn't stick. We have now completed that process. Put the rudder back. It is now fixed back to the steering cables, and you can see now, even though we are in fact moving the whole boat, we have very limited amount of movement in the top bearing. We can then check the movement at the bottom, and again with quite a bit of force, a little bit of movement, mainly because of the top bearing slightly being worn. We feel we've accomplished the job. The test will be next season to see how the bonding works, and along with other maintenance which include polishing the hull, anti-fouling, the usual checking the anodes, replacing anodes, checking the chain, which is, Athena is now ready for her next season. And let's go sailing. Thanks for viewing.